Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is surface areas and volumes. This is the part 1 of the video focusing on the NCERT solutions to the first exercise problems. Diameter of the base of a cone is 10.5 centimeter and its slant height is 10 centimeter. Find the curved surface area. We know the curved surface area formula is given by pi RL. R is the radius and L is the slant height. So we can substitute RL in this formula. Diameter is 10.5 centimeter. So radius is half of that, which is 5.25 centimeter. Slant height is given as 10 centimeter. So once we substitute, we get curved surface area as 165 centimeter square. Please note that pi is a constant and its value is given by 22/7. The second problem, find the total surface area of a cone if its slant height is 21 meter and the diameter of the base is 24 meter. Now once we have to calculate total surface area, it consists of two components. One is the curved surface area, we know given by the formula pi RL, and the base area. The base area is a circle whose area is given by pi r square. So whenever total surface area of a cone is required, we need to add pi RL, which is the curved surface area, plus the base area, which is pi r square. So if we take pi r common, we will get pi r into L plus r. This is the formula can be used for computing total surface area of a cone. Now just we have to substitute the values. Another important thing is that whenever slant height and base diameter is given, we need to convert this into radius first. So radius will be half of the diameter, which is 12 meter. Slant height is given as 21 meter. So we substitute these two in this formula. So total surface area of the cone will be 22/7, which is the value of pi into 12 plus 21, which is 1244.57 meters square. Curved surface area of a cone is 308 centimeter square and its slant height is 14 centimeter. Find the radius of the base. So curved surface area of a cone is 308. So 308 is equal to pi RL. Here we are given, which is pi RL is the curved surface area and it is given as 308. So from this we want to find the radius. L is given as 14. So we merely substitute here. Pi is 22/7 into R, which we need to compute, into L, which is 14. So we get R equal to 308 by pi L, which is equal to 7 centimeter. Now we need to compute total surface area. We have seen in the previous problem, total surface area is given by pi R into L plus R. Just substitute the value of R and L. We get total surface area as 462 centimeters square. Conical tent is 10 meter high and the radius of its base is 24 meter. Find the slant height of the tent and cost of canvas required to make the tent. The cost of 1 meter square canvas is rupees 70. Now it is important to note that whenever the height is given, here h is given and not L. 10 meter high and radius is given. So whenever h and r are given, we can compute L by the Pythagoras theorem. What is Pythagoras theorem here? L square will be equal to r square plus h square. That's what we have written. L equal to square root of r square plus h square. So we substitute this value. R is 24 and height is 10. So we substitute and get L as 24 square plus 10 square square root, which is equal to 26 meter. So now we need to find the cost of the canvas required. So for finding the cost, first we need to find the area. So curved surface area is given by pi RL. We substitute the value of R and L from here and get the area as 13728 by 7 meters square. this we have to multiply area into 70 because 70 is the cost of 1 meter square. So what will be the cost of this many meter square into 70? So that cost will be 13728 divided by 7 into 70, which is 137280 rupees. What length of tarpaulin 3 meter wide will be required to make conical tent of height 8 meter and base radius 6 meter? Assume that the extra length of the material that will be required for stitching margin and wastage in cutting is approximately 20 centimeter. Take pi equal to 3.14. So we got a tarpaulin which we want to convert to a conical tent. So how to find the length of the tarpaulin 3 meter wide? So if that length into 3 meter will be equal to the area of this tarpaulin plus the extra margin which we need to find. So we need to find the curved surface area of the conical tent. Now height is given as 8 meter and radius is given as 6 meter. 8 meter and 6 meter given. So we can find the slant height. Slant height is given by square root r square plus h square. So we substitute and get it as 10 meter. Now we can find the curved surface area as pi RL. So we substitute RL in here and take pi as 3.14. We get curved surface area is 188.4 meter square. So this curved surface area is equal to the tarpaulin from which we are making, which is a rectangular shape of length L and width 3. So we can equate this to area of the tarpaulin, which is rectangular in shape. Now width of the tarpaulin is 3, area of the tarpaulin is this. So area is equal to width into length of the tarpaulin. So 3 into length of tarpaulin is equal to 188.4, which gives length of the tarpaulin as 62.8 meter. This is the length. Now we have to add the margin used for wastage, which is 20 centimeter, which is equal to 0.2 meter. So we'll add this to 62.8. So we'll get the length of the tarpaulin as 63 meter. The slant height and base diameter of a conical tomb are 25 meter and 14 meter respectively. Find the cost of whitewashing its curved surface area at the rate of 210 per 100 meter square. So slant height and base diameter are given. R is 7 meter, slant height is 25 meter given here. So we can find curved surface area as pi RL. We substitute pi as 22 by 7, RL as 7 and 25. We get curved surface area as 550 centimeters square. This is 550 meters square. Now the cost is rupees 210 per 100 meters square. So what will be the cost per meter square? 210 by 100. That's what 210 by 100 is the cost per meter square. Now this many meter square will be into 550. So 210 by 100 into 550 is rupees 1155. So this is the cost of whitewashing the conical tomb. Joker's cap is in the form of a right circular cone of base radius 7 cm and height 24. So radius is 7, height is 24. Find the area of the sheet required to make 10 such caps. Now radius is 7, height is 24. We can get the slant height as square root of r square plus h square. Substituting the value of r as 7 and h as 24, we get L as 25 cm. Now the curved surface area of the cap is pi RL. Pi is 22 by 7 into 7 into 25, which is 550 centimeters square. This is the area of curved surface area of one cap. So we need to find for 10 such caps. So we multiply by 10. So total area of sheet required will be 5500 centimeters. A bus stop is barricaded from the remaining part of the road by using 50 hollow cones made of recycled cardboard. Each of the cone has a base diameter of 40 centimeter and height 1 meter. If the outer side of each of the cones is to be painted and the cost of painting is rupees 12 per meter square, what will be the cost of painting of all these cones? Take pi as 3.14 and take square root 1.04 is 1.02. So for getting the curved surface area pi RL, we need to find the slant height. So slant height is r square plus h square square root. R is 20 centimeter. So we need to convert into meter first. So that will be equal to 0.2 meter. Height is already given as 1 meter. So both should be in the same units. So L will be 0.2 square is 0.04. 1 square is 1. So this will be square root 1.04. And it is given square root 1.04 is 1.02. So it is given. Now the curved surface area is pi RL. Substituting the value of R and L, we get pi into 0.2 into 1.02, which is 0.64056 meters square. So this is the surface area of one cone. Now for 50 cones, this will be into 50. This area into 50 will be this. This is 32.0288 meters square. Now the cost of painting 50 such cones at the rate of 12 per meter square in this, so this will be multiplied by 12, which is equal to rupees 384.34. Friends, with this we conclude this video. Please like my video and subscribe my channel. This will help me to releasing the videos to you instantaneously whenever it is released. Thank you very much, friends.